Let's talk about something called salt solutions or salts in solution to see if they will be acidic or basic. So the word salt in chemistry really just means an ionic compound. Any ionic compound. Remember, ionic, it means it's made up of ions, and those ions are charged. So remember what we know about intermolecular forces and solubility way back from the beginning of general chemistry. Something that is charged, like ions, things that are in ionic compounds, are going to be aqueous. They're going to be aqueous because water is polar. And remember, polar has dipoles. Water has a dipole. So if I was to draw water up here, water would look like this. Water would have a dipole, a separation, where the more positive parts of the molecule would be the hydrogens down here, and the more negative parts of the molecule would be the oxygen up here. So because water is polar, ionic compounds are soluble in water because of the ion-dipole interactions. So, ionic compounds or salts are soluble in water, which means they are going to break apart. They are going to ionize in water to some degree, and we're going to talk about that in a little bit. But the reason that they'll ionize is because water is polar. Water has a separation of charge, and the separation of these charges are going to be attracted to the ions in this ionic compound or this salt. So, we are going to be determining if a salt is acidic or basic. So, how to determine if a salt is, let's say, acidic, basic, or neutral. How to determine if a salt is acidic, basic, or neutral. So the way that we do this is we're going to look at the cation and the anion of the salt separately. The cation, which remember is the positively charged anion, and the anion, which is the negatively charged ion. And then we're going to look at both of these and determine if a salt is acidic, basic, or neutral. So all of this is kind of nebulous, not very specific. So let's just use an example to see what we're really talking about. So let's look at a salt. So probably the most common salt is sodium chloride, table salt. This is an ionic compound. You know this is an ionic compound because it is made up of a metal and a non-metal. Remember, the metals are everything to the left of that metalloid staircase on the periodic table, and the non-metals are everything on the right. So just a quick review, everything over here, except for hydrogen, which doesn't really belong anywhere on the periodic table. These are all metals. So here you see the sodium. This is a metal. It's a positively charged ion. And then over here you find the chlorine. This is a non-metal. This is a negatively charged ion. Remember, the way you determine if the ionic charge of something is to see how many electrons something would gain or lose to be like its nearest noble gas, because that has a full outer shell. Sodium is going to want to lose an electron, so it's going to be Na+1. Chlorine is going to want to gain an electron, so it's going to be Cl-1. Okay, so just a little review about ions. So the first thing that we're going to do is we're going to separate sodium chloride into its ions. So I'm going to say what's the ion here and what's the ion here. So we just said sodium, this is Na+1, and this chlorine, this is Cl-1. These are the two ions that make up this salt, sodium chloride. So what we do is we see which acid or base this ion could have come from. So the positively charged ions are going to be conjugate acids of a base. And the negatively charged ions are going to be conjugate bases of an acid. So, what base is the sodium ion a conjugate acid of? So remember we talked about conjugate acids and bases way back at the beginning of this chapter, and remember it's the gaining or the loss of a hydroxide or a hydrogen. So sodium ion is the conjugate acid of the base sodium hydroxide. The chloride ion is the conjugate base of the acid hydrochloric acid. So you look at these ions that make up the salt and you see which acid or base did they come from. The positively charged ion will always have come from a base, sodium hydroxide, and the negatively charged ion will always have come from an acid. In this case, it's HCl. Okay, so we've established that part. First, we're going to separate the ionic compound into the cation and the anion. The next part is to determine if this salt is acidic, basic, or neutral. Well, you need to see, is this ion acidic, basic, or neutral? Is the sodium ion acidic, basic, or neutral? Is the chloride ion acidic, basic, or neutral? The way you determine if it's acidic, basic, or neutral is you look at its conjugate. So here are two rules. The first rule is the stronger the acid, the weaker the conjugate base. So, for example, strong acids, like the 6 strong acids, their conjugate bases are neutral. So the stronger the base, the weaker the conjugate acid. So, for example, a strong base is going to have a conjugate acid that is neutral. If you had a weak acid, I'll just write this out. The conjugate base would be a weak conjugate base. A weak acid, I'm not going to write that on this slide. We'll get to that in a minute. Just let's look at this as an example. So the way we determine if sodium chloride is acidic, basic, or neutral is by looking at the ions that it breaks up into and determining if they are acidic, basic, or neutral. So the sodium ion, because it is the conjugate of a strong base, so a strong base like sodium hydroxide, that means the conjugate, sodium, is neutral. And a strong acid like hydrochloric acid, the chloride ion is also neutral. So what's happening here is when we have a solution, let's say we have a beaker and it's got water in it, and we put sodium chloride solid in it. When we put it in here, the sodium chloride breaks apart into sodium ions and chloride ions. There's no more sodium chloride because these are both strong acids and bases. It breaks apart into sodium ions and chloride ions. So if this water was neutral and you put a neutral sodium ion and a neutral chlorine ion, chloride ion, it's not going to change the pH of the solution because sodium chloride is a neutral salt. It is a neutral salt because it is made up of two neutral ions. So this is not always the case, because if one of these ions was the conjugate of a weak acid or a weak base, then the conjugate would also be weak, meaning it would contribute to the pH. But because both of these are conjugates of the strong acids and strong bases, it's a neutral salt. It's important that you remember these 6 strong acids and 7 strong bases, especially when we're talking about salts, because when you're identifying a salt as being acidic, basic, or neutral, you need to know if it is acidic or basic based on the conjugates, those ions. Are they conjugates of a strong acid? Are they conjugates of a strong base?